Hello everyone, in this video we are going to be deriving the kinematic equations using calculus and integration. So remember that the kinematic equations apply when situations have constant acceleration. So constant acceleration. And one way to define the constant acceleration is that the average acceleration is equal to instantaneous acceleration at all times. And if you were to graph this, it would be a straight line, a straight horizontal line, if you have acceleration over time. So remember that acceleration is equal to the change in velocity over the change in time. And as change in time approaches zero, we have that acceleration is equal to dv over dt. Now remember that velocity itself is equal to change in position, or the displacement over the change in time, and that as time approaches zero, again, change in time approaches zero, we have velocity is equal to dx over dt. So that means acceleration is equal to d squared x over dt squared, or the second time derivative of position. Now, since acceleration is constant in kinematic equation situations, we have the acceleration d squared x over dt is equal to a constant value, which we will call a, dt squared here, sorry. So now if we move this dt squared to the other side, we have d squared x is equal to a dt squared, or using this form right here with dv dt, we have dv dt is equal to a, and dv is equal to a dt. Now, focusing on this last part right here, we can integrate both sides of these equation. So we have the integral of 1 dv, because there's a 1 here, is equal to a, which remember is a constant, since it's constant acceleration, dt, and that's integrated. So 1 is integrated with respect to v, and that just gives you v. Now there's a constant of integration here, but since we're integrating both sides, we only need to put the constant of integration on one side. And so v is equal to at, since we're integrating a, which is a constant with respect to t, plus c. Now, this plus c occurs when t is equal to 0. So when t is equal to 0, we have v is equal to c. And so when t is equal to 0, the velocity is also known as the initial velocity, or v0. So v of 0 is equal to v0. And now, but we also know that v of 0 here is equal to c. So that means c is equal to v0 in this case, which gives us our first kinematic equation of v is equal to at plus v0. All right. Let me box this. Now, remember up here we said that the velocity is equal to dx dt. So if we replace our velocity here as dx over dt, and then set that to at plus v0. Remember, a is a constant, and in this case, v0 is also a constant because it describes the velocity at a single point in time. So that means that we can integrate this side with respect to t as well. And so if we move the dt onto the other side, we have dx is equal to at plus v0 times dt. And now integrating this like we did above here, we have the integral of 1 dx is equal to the integral of at plus v0 dt. And that gives us that x is equal to 1/2 at squared plus v0t plus, again, the constant of integration. Now we know that when we have x at time 0, we can call that the initial velocity, the initial position. And also when we have at x equal at time 0, these two terms cancel out since they're multiplied by 0 as t is 0 at time 0. So that means that x of 0 is equal to c, and so that gives us that the initial position, is equal to c. And that gives us our last kinematic equation, in that the position is equal to 1/2 at squared plus v0t plus x of 0. Now, normally you see this as, if you move the x0 to the other side, we have x minus x0, which is also known as the displacement, is equal to 1/2 at squared plus v0t. And so that is another kinematic equation. And now, using calculus and integration, we have derived that the velocity is equal to acceleration times time plus initial velocity, and the displacement is equal to 1/2 of acceleration times time squared plus the initial velocity times time. And using these two equations, we can derive all the other kinematic equations just using simple algebra. So that is how the kinematic equations are derived using calculus, and that is how you can use calculus given constant acceleration to find the velocity at a point in time and the displacement given a period of time. All right, thank you.